Okay. Please. We could go on forever here. So please be seated. So a warm welcome. It's great to see so many of you here on this general press conference. And of course, a particular welcome to our Nobel Laureates of 2014 that you have here on the podium, ready to answer your questions. Introduce myself. My name is Staffan Normark, and I'm the permanent secretary of the Royal Swedish Academy of Sciences. And now the introduction of the laureates. So, the Nobel Prize in Physics 2014 was awarded to Professor Hiroshi Amano, Nagoya University, Japan, and Shuji Nakamura, University of California, Santa Barbara, California, USA. And they share the prize with Professor Isamu Akasaki, Mayo University, Nagoya, and Nagoya University, Japan. Professor Akasaki could not participate in this press conference. And they received the prize for the invention of efficient blue light emitting diodes, which has enabled bright and energy-saving white light sources. And the Nobel Prize in Chemistry 2014 was awarded to Professor Erik Betzig, Janelia Research Campus, Howard Medical Institute in USA, to Professor Stefan Hell, Max Planck Institute for Biophysical Chemistry, Göttingen, and German Cancer Research Center, Heidelberg, and Professor William Moerner, Stanford University, Stanford, California. And they received the prize for the development of super-resolved fluorescence microscopy. The Sveriges Riksbankpris in Economic Sciences in memory of Alfred Nobel 2014 was awarded to Professor Jean Tirole, on the right, Toulouse, Capital University, France, for his analysis of market power and regulation. Well, our laureates have been pretty exposed to media. They have learned to answer all kinds of questions. And you have in front of you an eminent panel of laureates. It's not every day you have this opportunity, so I will now leave the floor open to you to pose questions. But before you do that, please introduce yourself with a name and the media that you represent, and use the microphone. And also, please, the conference will be in English. The first question there.
Thanks very much. Congratulations, Professor Tirole. A question for you. Li Wei from Taixing Media from China. So this year's economics field is pretty much dominated by French. With you winning the Nobel Prize, Thomas Piketty's book swept the world. And in the IMF recently selected 25 young economists under 45. 7 are French, including your co-author, Emmanuel Fahy. I'm just wondering, traditionally the French education system is pretty rigid. What French did right in recent years? Why is French economy thriving? Thanks.
Well, thank you for this question. I'm sorry. Yeah, France has been doing very well in economic research in the last few years with lots of good young people. I'm on the older side, of course. And they have been trained very well in mathematics and other fields. There's no French touch. There's just plenty of human capital, I think, operating. But you have to remember that out of the 7 you mentioned, which were selected by the IMF, 6 are working outside France. So we really have to get them back, and that's what we are trying to do in Toulouse, and also some others in Paris are trying elsewhere to try to get back the brains back to our country. But it's basically a very good training in mathematics and other fields, I think, which explains this.
Do I have other questions? Was there a question somewhere there?
There's one in the back.
One in the back? Where? There is one question.
Yes, my name is Kazuki, working with NHK. I have a question to Professor Amano and yes. Nakamura. What do you think about the importance of receiving this prize and the secondly, there is a series of Japanese researchers receiving this Nobel Prize in recent years. And how do you think about the level of the Japanese science is growing, improving, or how do you think about it?
I think the importance of this prize is that because through this prize, general people could understand the importance of the high efficient blue and white LEDs in order to save energies, especially to solve the global warming issues. So that's the most important thing because general people have to notice the importance of this technology. And the second question is, recently, a lot of Japanese people, scientists get winning a Nobel Prize. So I think because one point is Japanese people are very, study very hard and honestly. So that's important, for the field of science, because Japanese people can make a very high quality product, and by assembling a high quality product, we can make very noble tools. By developing noble tools is very important to invent something new. So that's the reason I think recently Japanese people are getting a lot of Nobel Prize.
From the academician point of view, the innovation-oriented research was not so easy at the time, but we were very proud that this innovation-related research is awarded the Nobel Prize. So maybe this message is very important for the younger generations. And also, the Japanese, I don't know. Maybe in Japanese, the fundamental research is important. And the Japanese academia was focusing on the fundamental science. That's why the Japanese are there are so many Nobel Prize.
Okay, thank you. No, it is an interesting year because you know that the Alfred Nobel, he wrote in his will that the physics prize could be awarded to discovery or invention of benefit for mankind, and he wrote that the chemistry prize could be awarded to a discovery or an improvement. And I'd like to pose the questions to the chemistry and physics laureate, how they feel if they are, if that's proper for them, that they have improved the light microscopy, but they have also made big discoveries. And the same is true for physics. So what do you feel?
I think it's a very good point. I think it's a point that it's worthwhile discussing. Definitely what we have done is an improvement. We have improved the resolution of a light microscope over a factor that wasn't anticipated. So basically circumventing the diffraction barrier such that you can go down in principle to the molecular scale. However, I think it's very important to realize that such an improvement is also based on a discovery. You have to first realize that you can solve the problem, although the problem seems to be unsolvable. And secondly, the basis of this improvement is another discovery, which is to use the features of the molecules, the molecular states, for the separation of adjacent objects, adjacent features. And this is totally different from what was done before. So again, this has an important element of discovery. So I think discovery requires curiosity, and one should not underestimate the importance of curiosity and discovery for making improvements that are in the end practical.
Yes, in particular, if I can comment about that, in the 25 years ago when we first observed single molecules in a solid, that was an esoteric basic science experiment, just exploring the frontiers, measuring something that could not be measured before. And while much was learned while studying individual molecules that was surprising, we did not expect, it's wonderful that with the ideas of being able to control the molecules and their concentration, you can use them as light sources to produce a super resolution image even in cells. So there's a combination of both aspects, the fundamental discovery without really knowing what the applications might be, and then later really exciting applications that appeared.
So I guess I consider myself more of an engineer than a scientist, so I don't really see a distinction between discovery and invention. Is that to me it's a chicken and egg problem. A good example is single molecules, which was inspired in part while WE was at IBM with spectral hole burning as a possible solution for data storage. And then that led to the single molecule discovery in basic science, which then led to the eventual application of super resolution. So there's just this constant wheel going round and round between applied and basic research. And just like I don't make a distinction between the physics prize and the chemistry prize and the medicine prize, these boundaries are arbitrary. And I think this thing about discovery and invention, they're two different sides of the same coin.
Thank you. There.
Good morning, my name is Corina Negra, I'm coming from Radio Romania Science Department. I have two questions, maybe three, if possible. The first one is for Professor Hell, and I would like you to be so kind to recall the moment when you realized that you made a real important discovery. The second question would be, so all of you, mainly chemistry and physics, and economic sciences, you proved that your theories, that your discoveries are important. So what do you think that this Nobel Prize will change, basically and fundamentally? And the third, if it's possible, if it would be possible, yesterday Professor O'Keefe was asked about, he was very critical about the immigration law in the UK. He said that the immigration laws can restrict research, and I would like to hear your opinion. It's not the case in the US and in Germany, maybe. But I would like to hear your opinion on this. Thank you.
Okay, related to the first question, so I got this gut feeling that it would be possible to improve the spatial resolution already at the end of the 80s, around 1990, when I was still in Heidelberg, but I didn't have a very concrete idea how to overcome it fundamentally. When I worked not very far from here, actually in Turku, in Åbo, in Finland, I realized at some point that stimulated emission would be one way of overcoming the diffraction barrier by turning off molecules for a brief moment. And this was a eureka moment, so I realized this is most likely the way to go. Turning them off, keeping them dark so that you don't see neighboring features at the same time. And eventually this turned out to work well after, of course, a lot of development. Again, so this is the discovery, but again, you have to improve it and to make it viable. The other question, I think, were directed to the others.
Okay. What this prize will change in your professional life?
In my professional life?
In all of your professional lives?
I hope it doesn't change much because I think most of us, I can of course speak for myself, like what we do. So I like to be a scientist, to do things that are interesting, that are challenging, work at the edge between knowledge and things that are unknown. So I hope it doesn't change much in that respect. It may make things easier to some extent because there is a lot of recognition, of course, connected with this prize. And this may even help being more adventurous and tackling even more challenging things. And this is something that I wish, at least, for the near future.
Okay. Yeah, I of course feel something also like a responsibility because the Nobel Laureates are treated with great respect. It will be possible to perhaps help a bit to improve education and to try to get more young people interested in science. This is a very difficult problem in our world, and we all worry about it, that we want to find ways to encourage young people to go into science and continue to feel that passion and that excitement of how does this work, how does this really work, and I hope that we will be able to spend some of our energy toward that end. But I agree, of course, with Professor Hell that it would be great to have a little more freedom to innovate more and without as many concerns, let's say, about funding.
Okay. I think I had a question over there.
Hello, I'm from the newswire AFP. You just say, I have a question for Jean Tirole. You just said that France has been doing very well in economic research lately, but how could France do very well in economics in general?
Well, it's a very tricky question, of course. I mean, I think we have to follow the lead of countries like Germany and Sweden, actually, which had difficult moments themselves, and they have done a lot of reforms. We are in a tough situation right now, but as I answered Li Wei earlier, we also have a lot of assets. It's not just, fantastic heritage we have, cultural and physical heritage we have, but we also have a lot of highly trained people. So my view is that I would not be in France if I didn't believe in France fundamentally. So it's just that we have to go through the reforms to make people back to work. For example, the unemployment rate in France is actually very high, especially if you take into account disguised unemployment. And also to do the reform of the states, things like that, I mean, which many countries have done, like Canada and Australia and Sweden, because what they have shown is that you can keep the welfare state, which the French people care about, and they are right to care about it. You can keep the welfare state while having a lighter state itself, so that makes it sustainable. And that's very important because, if you don't have a sustainable economy, your debt is rising and so on, then at some point you'll have to get rid of the welfare state, and that will be quite a disaster in my view. But we have to prepare the future and follow the lead in particular of this country here.
I think we had a question there, yeah?
My name is Maria Gunther. I'm from the Swedish newspaper Dagens Nyheter. I have a question for the laureates in physics and chemistry. You were all doing things that others in your field thought was impossible. So I wonder what made you carry on? And also another question, what would be your best advice to a young person wanting to make a career in science?
Okay. Okay. Basically, I like basically solve the problem, any kind of problem. So research means always there's a problem, and I have to solve this problem, and next problem happens, so and solve the problem. That is, I like to solve the problem, like problem is like a quiz. So that's the reason I could continue, the research, almost impossible research of blue LEDs. And for young scientists, I think the most important thing is to try to challenge a totally new thing, totally new and new thing that nobody has achieved. Challenge a totally new thing. That's the most important, challenge. Challenge the totally new idea, abnormal idea, So don't afraid the challenging totally new thing. That's the most important. So take a risk. Most important, take a risk, Even the people, young scientists don't take a risk, no big breakthrough, So most important, take a risk, try new thing.
For me, the most important thing is to contribute to the people. That's why I'm interested in the blue LEDs. And for young generations, I'd like to say that to contribute more or try, the similar to Professor Nakamura, that to try and to challenge for the contribution of mankind.
I mean, I definitely agree. It's very important for young people who enter science to select very carefully what they do. My personal advice would also be to look into problems other people didn't really look into. It's very important to find something interesting. I think even the selection of a problem is a creative act and is an invention on its own, so to speak, or a discovery. In my particular case, if you ask me why I carried on, well, after I realized that you could overcome the diffraction barrier, in this particular case, the stat concept and related concept, Of course, I was very critical to myself and to my own idea, and then asked where are problems, and many people pointed out the problems, and most of them said actually it won't work. Then I analyzed the problems, and I separated in two classes. One was conceptual, and the other one was technical. And when I looked at the conceptual things, I realized there is no error in it. So conceptually, it's absolutely sound, and the criticism related to technical things. And the point is that conceptual things probably are going to stay for a long time, but technical things you can sort out, and or other people sort it out, better detectors, better dyes, and so on. And this was correct. And so you can stick to your idea if you know that it's conceptually right. Now, in order to make this distinction, you have to have a very, very good education. So I benefited in this case from a fantastic education, this case in physics that I had received in Heidelberg in Germany, and this helped me going on because I knew conceptually I'm right, and that gave me the strength to go ahead.
Sure. So I'm just echoing a little bit what you've already heard. I agree with what Stefan said is that to any young scientist coming on, you have to start making your own opinion. Physical law is just a reflection of what we've learned from experiment, and it's rewritten over and over and over again. So you have to make your own decisions about where are the loopholes in these laws if you want to move ahead. I'd also like to say, related to what Shuji was saying, is about taking risks, is that I totally agree with that, but the flip side of it is you have to accept that the flip side is failure, and you're going to fail more often than you succeed. And so you have to be willing to accept failure and embrace failure. And the way that you continue to work towards a success is, first you have to be passionate about the problem that you choose, because then you need to work extremely hard. But if you're passionate about it, it's easy to work hard. And then lastly, to echo what Stefan said, is self-criticality. Is that you need to be your own toughest critic in your work and make sure that you're not fooling yourself. But if you put all of those ingredients together, I think that you have a recipe for success.
Well, let me add, I'm going to echo a little bit those themes. And as an economist, I chose economics because it was a normative science as well as a positive science. And there are lots of very interesting primes. And actually, I agree with everything which has been said, and in particular about the chicken and egg prime, which is myself, I do fundamental work. So I'm a theorist, but at the same time, working with regulators, working with various parties, I've discovered a number of new issues, and then the theory I've done has been applied in practice quite a lot. So it's hard to distinguish between fundamental science and applied science, and I'm just echoing what was said. And then you also have to be there in the debate as an economist. It's very important. We have lots of challenges. We are in an ivory tower. You have to work out, and there are lots of issues right now, and one of them which preoccupies us quite a lot right now is the environment with global warming. And, for example, economists have been long environmentalists trying to explain you needed a price for whatever pollution there is, carbon, and we have solutions right now. And, we have to explain that because, if you look at what's happening in politics right now, all over the world, we are not going to solve the CO2 prime, the greenhouse gases prime, with the solutions which have been proposed. So we economists also have to contribute to that and explain how to do it. And there is you have to price carbon, worldwide, and that's as simple as that. And then there are more complicated things. So, but there's just an example. We have to engage in a public debate, and that's also what makes economics so exciting, I must say.
Okay, thank you very much. I think time is passing, and we have to close this conference. And I hope that so many of you as possible are coming tomorrow to the Nobel lectures in Aula Magna. So thank you very much.